All right, ladies and gents, time for a lesson on polar coordinates of complex numbers. So the reason we had our little review of complex numbers is so we can tie it into polar coordinates, because you can take complex numbers and convert them to polar coordinates. And yeah, so remember that once upon a time we had like polar coordinates like in the form a plus bi, and this would be the real part, this would be the imaginary part, and you would just go horizontally a amount, the real part, and vertically the imaginary part. You're graphing it, turn into a vector. So it looks something like this. Well, this is oddly similar to polar coordinates and rectangular coordinates, so they're all related to each other. Well, if this is your complex number, you can convert this to polar coordinates by figuring out, well, how far out it is, which we call the radius, which when we were dealing with complex numbers, that's called the modulus. So radius equals modulus. They're the same thing. And then we have to find the angle here. Well, once upon a time, as in that last time we dealt with polar coordinates, you can get that angle just by doing the inverse tangent of the opposite side over the adjacent side, which we'd call the opposite side the unreal part, the imaginary part, and then the adjacent side is the real component. And you can get these things. Oh yeah, sorry, I forgot to mention that the modulus here is just x squared plus y squared, and then you square root it. And so you can get those two bits of information pretty easily. We did that, last time with polar coordinates, but we're going to do it this time with complex numbers. But instead of writing your answer as just r theta, like that, we're going to be writing it as this expression here. Let me kind of highlight it. It looks like this. And this kind of lets you know that it's a complex number because we got this I here. And yeah, it's just a different way of writing it. So this is how we're going to do it. So let's go through the steps. You're going to compute the modulus using x squared plus y squared, and you square root it. You'll get the angle by using inverse tangent. And once again, you need to make sure your calculator's in degrees and make sure your angle is in the right quadrant. And then you're going to put it in this format. And that one has all the information you need for your polar coordinates for this complex number. So let's go ahead and do that. We're going to convert to polar form and then graph it instead of just graphing it straight away. Okay, so we need to first get our modulus, or the radius here. And so we're going to do square root of 3 squared plus 3 squared, right? Because you just got 3 and 3. Which means this is just going to be the square root of 9 plus 9, which is 18. And you can rewrite 18 as just 3 root 2. Remember, because 18 is 9 times 2, and 9 is 3 times 3. Okay, we can also get our angle. We're just going to do inverse tangent of y over x, or the imaginary part over the real part, but don't put the I in there, so it's just 3 over 3. Which I can use my handy-dandy calculator here. Really, it's just inverse tangent of 1, because 3 over 3 is 1. So we get 45. We need to check and make sure this is in the right quadrant. The complex number 3, 3 would be out here. So yes, this is in the correct quadrant, 45 degrees there. Okay, so we got that. We got our two pieces, the angle, we got the radius or the modulus, and now we're going to write it in this form. And you're just going to put z equals r, which is 3 root 2. And then in parentheses, you got cosine theta plus I sine theta. So cosine of 45 degrees plus I sine of 45 degrees. Yeah, that's it. That's the whole thing in polar coordinates for this complex number. I know it's a little bit different format than we had yesterday, but it has the same pieces. It has r, and it has our theta in there twice. Okay, and so now we can graph this. We're going to go out 3 root 2 and go at a 45 degree angle. So 45 degrees is out this way, and come on up here, and this can be 3 root 2, and hooray, we did it. ta-da! Yeah, like that's it. We did it. That's the graph there, which should match up with what we expected. Right, you go to 3, 3, and that's what it is. But kind of the primary thing you need to do is convert to this format. Okay, so that's how you convert a complex number into polar coordinates or into a polar form, because it's not polar coordinates. Yeah, so that's what it is. Let's try out another one so you can see it in action again. So this is our x part. Our y part here is just 1. And so now we can get our modulus. So r is going to be negative root 3 parentheses squared plus 1 squared. If you don't put parentheses, this is going to be wrong. So make sure you put parentheses. The negative square root of 3 squared is going to come out to be 3. And 1 squared is 1. So it's the square root of 4, which is 2. Oh, nice number there. Now we're going to get our theta. We're going to do inverse tangent of 1 over x, and x was negative root 3. Go like that. And you can just put that whole thing in your calculator. So you got 1 divided by negative square root 3. I got negative 30 degrees. Once again, we need to make sure this is in the right quadrant. So I'm going to come over here, see, negative root 3, 1. Negative root 3, 1, it'd be in this area up here. But we got an angle down here, right, negative 30. And so to fix it, we need to get it over there. And we can do that by adding 180. So kind of like that last time when we were dealing with polar coordinates, sometimes you just have to add 180 or add 360 to get it in the right quadrant. So we're going to do theta is going to equal 150. Nice. So we got r, we got theta, and now we can write it out. Z is r, just 2, times cosine of 150 plus I sine of 150 degrees. And now we got the polar form of this complex number, and we're going to go ahead and graph it. I actually kind of sketched it out already. We need to go left square root of 3 and then up 1, which is going to end up over here. Because square root of 3 is, about 1.7. So we're looking at something like this. There we go. We graphed it. Ta-da! So that's how you convert a complex number into polar form, which is not quite the same as polar coordinates, but it's got the same idea. You need to get a radius, you need to get a theta. You just write out your answer in a little bit different format. So yeah, that's how you convert that way. Your assignment has you do that, and then it has you go the other way. Luckily, going the other way is easier because you just need to figure out what your radius and your angles are, and you distribute. You really just distribute, and you simplify things down. And we're just going to write out, yeah. So now we got 2 times the cosine of 135 degrees. And we got plus 2, square root of 2, not just 2. Sorry, square root of 2, I times sine of 135. I do want you to get the exact values of these because things are going to simplify pretty nicely. So yeah, go to your unit circle, look at cosine, which is the x-coordinate for 135. Go to sine, which is the y-coordinate of the angle for 135, and you can write them down. So I'm actually going to pull that up. See, I go to 135, it's over here, and they're both root 2 over 2, but the x one's negative. So I'm going to go back here and go there. See, so now I got square root of 2 times, the x one is negative, root 2 over 2, and now we got plus root 2i times the positive square root of 2 over 2. And we're going to simplify this down. Square root of 2 times square root of 2 is square root of 4, which is just 2. So now we got 2, negative 2 over 2. And this one over here, we got 2i over 2. And 2 divided by 2 is just 1. So now we got negative 1 plus 1i, and we got a lovely complex number here. So to get it into rectangular form, you just need to distribute and simplify the expression down. But now we got -1, 1 is here, and we got a graph pretty quickly. Just draw a vector that goes to -1, 1. Hooray! So yeah, pretty quick there, and these ones are a similar vein. Just distribute and simplify things down. So there you go. There's a complex numbers and polar form, which is different, but it's dealing with complex numbers and polar coordinates all together.